about the history of the atomic bomb.
Wait, Mrs. Medina, what are you talking about?
Well, a long time ago,
I wonder how many times I could break this in half until I couldn't anymore. There has to be a point where... Crikey, I've got it! The smallest particle must exist. Any other explanation would be completely illogical. Cutting this more and more must eventually produce a particle that can no longer be divided. Yes, and I will call this particle the atom, after the Greek word meaning indivisible. It would make no sense otherwise. This will be my philosophy. I will go down in the books, teach it to my pupils. I will be known as the man who created the atom.
and that's how the first idea of the atomic model was made.
But there has to be more, right?
Why, of course. Let me tell you about a man named John Dalton.
Dear Diary, after much research, I have come to the conclusion that all elements are indeed composed of tiny particles called atoms. An atom cannot be created, divided, destroyed, or changed into any other atom, for atoms of different elements have different properties. Ooh. Atoms of different elements, however, can combine together into whole number ratios to form compounds. But atoms of the same element have identical properties.
I do believe that I have created the most advanced atomic model in the history of the world. That old philosopher Democritus has got nothing on this, and I will call this the solid sphere model.
And yes, this model has a big similarity with a bowling ball.
So I'm guessing he isn't the last of the atomic thingamajiggy inventors, right?
Not even close.
Oh dear, what in the world was that? I will call these movements the cathode ray. If the cathode ray is attracted to a positive electrode and repelled by a negative one, well, yes, the cathode ray is actually just a stream of negatively charged particles. I will call these particles corpuscles. Ah, this is brilliant. Yes, an atom must be made up of positively charged materials with these negatively charged particles just stuck in randomly. Well... Ah, plum pudding! Yes, that's what I'll call it. Thomson's plum pudding model. Creative and delicious.
Anyways, J.J. Thomson wasn't the last person to contribute to the history of the atomic bomb. Now we're going to talk about Lord Ernest Rutherford.
Whoa! Wow, would you look at that? The alpha particles went straight through the gold foil. Do you believe it? No! That proves that an atom is made up of the mostly empty space with the small dense center region that holds most of the mass and positive charge. I shall call this region the nucleus.
This was called the Rutherford model.
And this next person actually connects to Rutherford because he basically just expanded his ideas and focused more on electrons. And his name was Niels Bohr.
This is a line prime beat production.
Hey, let's go. My name's Niels Bohr and my model's about to soar. But first, let's start from the beginning. I'll tell you about how Bohr is winning. Rutherford's model was my muse. And then I came to expand his news. He was all about the nucleus, but electrons were the grooviest. They orbit round the nucleus in a fixed circular motion, somewhat like the solar system's notion. When they change their orbit, a quantum leap occurs. So if you ain't ready, this ain't for amateurs. Any charged particle is gonna give off radiation, and this is called the photon station. So Rutherford was missing a lot. And guess what, fool? You just got caught.
Hey, wake up! Huh? You didn't get any of that, huh?
Oh no, I think I got it.
Well, here, let me show you a little demonstration.
The last people we're going to talk about today is Schrödinger and Chadwick. These two men worked together and expanded Bohr's research. Schrödinger realized that electrons don't move in orbits but in waves. This introduced the concept of sub-energy levels. Next, Chadwick discovered the neutron. The neutron was really hard to find because it didn't repel the protons when they were in the atom. And now, with this new discovery of the neutron, a satisfactory atom model was made and was capable for the use of chemists. Chadwick had won a Nobel Peace Prize in 1935. Now, I hope that you all understand the history of the atomic model.
Time already? Well, I guess there's no homework then.
Yeah!
Oh, but there is a quiz tomorrow.
Thanks for